All right, how are you doing? My name is Miss O'Connell and I am a teacher at Walter Johnson High School, and I am going to be working with you starting with page 13 of the Montgomery County Public Schools Geometry A Semester Exam Review. And in number 36, they are asking us about two parallel lines cut by a transversal. So we first need to make sure that we understand that vocabulary. Two parallel lines are two lines that are never going to intersect. And remember that lines go on forever in each direction, so we use arrows to show that. So those are two parallel lines, and they are cut by a transversal. So a transversal is any line, it could be coming in any direction, that intersects both of those parallel lines. And again, it's a line, so I'm going to draw arrows on each end of it. So which pairs of angles are congruent? And I'm going to label up here that this is our transversal. So which angles are congruent? Well, I can see that there are smaller angles here and here, and here and here. And all four of those angles are congruent to one another. And we have names for them. And I want to be sure that we know the names of each pair of angles. Okay, so I'm going to number my angles to help us see this. 1, 2, 3, 4, 5, 6, 7, and 8. So I have 8 different angles, and we've said that angles 1, 3, 5, and 7 are congruent to one another, but I want to know what they are called. So for part A, angles that are congruent would be angle 1 is congruent to angle 5, and angle 3 is congruent to angle 7 for the same reason. Both of those pairs of angles are called corresponding angles. And the way I think about corresponding angles is that they're in the same location in the intersection. So if I think about this top intersection here, angle 1 is in the top position, sort of the top right position of this intersection, and angle 5, if I look at this intersection, is in that same exact position. So those are corresponding angles. They're in the same position in a different intersection. And the same is true about angle 3 and angle 7. Okay? Likewise, angle 2 is congruent to angle, can you fill in the blank? Which one is congruent to angle 2? Angle 6, because they are corresponding angles. And angle 4 is congruent to angle 8 because they are also corresponding angles. Okay? So all of those are examples of corresponding angles. I also have angle 3 is congruent to angle 5. And those are congruent to one another for the same reason that angle 4 is congruent to angle 6. They're not congruent to each other. 3 and 4 aren't congruent to each other, but 3 and 5 are congruent, and 4 and 6 are congruent. And these are what we call alternate interior angles. And the reason they're called alternate interior angles is they are on alternate sides of the transversal. Notice 4 and 6 are on different sides of the transversal, and they are in the interior, in here, of the parallel line. So if I highlight the interior, all of this is the interior. Okay, so 4 and 6 are alternate interior, 3 and 5 are alternate interior. Okay, and I have one last set of angles that I want to describe are congruent to one another, and that is angle, oops, that's my highlighter. Angle 1 is congruent to angle 7 for the same reason that angle 2 is congruent to angle 8. So hopefully you're noticing that angle 2 and angle 8 and angles 1 and 7 are on alternate sides of the transversal, but these aren't alternate interior angles because they're not in between the two parallel lines. These are alternate exterior angles. Okay? And so corresponding angles, alternate interior angles, and alternate exterior angles are the three types of congruent angles you find when you have two parallel lines cut by a transversal. Then they ask us which angle pairs are supplementary. So I need to know what that word supplementary means in order to answer this question. And that word means that the angles add up to 180 degrees. Okay? And so when I'm talking about supplementary angles, I am looking not at congruent angles, not at angles like 3 and 5, those are congruent, but rather I know 5 and 6 are supplementary because they make a straight line. And if 5 and 6 are supplementary, well, I know 3 and 5 are the same, so 3 and 6 must be supplementary. So angle 3 and angle 6 are supplementary. This is part B where we're looking for supplementary angles. Angle 3 and angle 6 are supplementary, and angle 4 and angle 5 are also supplementary for the same reason. These aren't alternate interior angles, although they are in the interior of my parallel lines. These are what we call same side interior angles. And you might have guessed that we call them same side interior angles because they are on the same side of the transversal in the interior of the parallel lines. Okay? And then I know that 7 and 8 make a straight line together, so they also add up to 180 degrees. 7 and 8 are supplementary, but those aren't formed by the two parallel lines cut by a transversal. I want to look bigger than that. So if 7 and 8 are supplementary, well, what do I know is congruent to 7? I know 1 is congruent to 7 because they're alternate exterior. So angle 1 and angle 8 must also be supplementary. Since 7 and 8 are, and 1 and 7 are congruent to one another, 1 and 8 must be supplementary. Okay? Likewise, 1 and 2 are congruent to one another, but what's congruent to angle 1? Angle 7. So angle 2 and angle 7 must be supplementary because I can substitute that angle 7 in for 1. And these are supplementary because they are same side. Notice that 1 and 8 are on the same side of the transversal, and 2 and 7 are on the same side of the transversal. These are same side exterior this time. Okay? So the angles that I have that are supplementary are same side interior angles and same side exterior angles. Now, I'm just going to talk about a little bit more vocabulary, and what I'm going to talk about now are not angles that are formed necessarily by two parallel lines cut by a transversal, because you don't need two parallel lines cut by a transversal for this. But if I just have one line and a second one intersecting it, I have more congruent angles and I have more supplementary angles, and I just want to review that vocabulary. So here I only have 4 angles, and I know what about angle 1 and angle 3? What's true about angle 1 and angle 3? I hope you said that they are congruent to one another for the same reason that angle 2 is congruent to angle 4. Can you tell me what kind of angles 1 and 3 are and 2 and 4? What do we call them? They are congruent because they are vertical angles. So that is some more vocabulary to know. Notice I didn't need two parallel lines cut by a transversal. Any two intersecting lines create vertical angles. Okay? And then we know supplementary angles are any two angles that make a straight line. So what pairs of angles are supplementary here? I have several. So I just showed you angle 1 and angle 2 are supplementary because they make a straight line. How about angle 4 and angle 3 are supplementary because they make a straight line? Any other pairs? Angle 1 and angle 4, angle 2 and angle 3. Notice these two together make a straight line. So those are additional pairs of supplementary angles, and we call all of these linear pairs. And that's because we see them making a straight line together. On the last slide, we looked at supplementary angles, but they didn't sit right adjacent to one another to make a linear pair. Okay? So that's just some more vocabulary. And now we get into some parallel line proofs. Okay? So we can do a flowchart proof. We could do a paragraph proof. I am going to stick to a two-column proof because we're probably most familiar with that. And I'm going to put my statements on the left and my reasons on the right. And I like to, right off the bat, list what's given to me. So I always list the things that they tell me are true. So M is parallel to N, and my reason for that is it's given to me. So I mark that. I use these little carets to show that those are parallel lines. The other thing they tell me is that angle 1 is congruent to angle 16. Again, that's given to me. And so I'm going to mark that on here. Angle 1 is congruent to angle 16. Okay? So somehow they want me to show that P is parallel to Q. Well, I know that I'm going to need some congruent angles to show that P is congruent to Q. So let me think about this a little bit. What angles do I know are congruent to angle 16? Hopefully you're saying, I know angle 13 is congruent to 16 because they are vertical angles. Hopefully you're also saying, I know angle 5 is congruent to angle 16 because they are alternate exterior angles. Well, which one of those is going to be useful to me? I'm going to say that angle 16 is congruent to angle 5. And we said that's because they are alternate exterior angles. So notice they are in the exterior. I know this line and this line are parallel. They are in the exterior of those parallel lines. Okay? And they're only crossing the transversal Q. So angle 16 and 5 have nothing to do with transversal P at all. Well, if I know that angle 1 is congruent to angle 16 and 16 is congruent to 5, hopefully you're thinking, I know that angle 1 has to be congruent to angle 5. And that is because of something we call the transitive property of congruence. The transitive property says if one thing is congruent to a second and the second thing is congruent to a third, then the first and the third must also be congruent. For instance, if I said, I know that when I go to the vending machine, Skittles cost as much as a soda, and a soda costs as much as Sun Chips, then Skittles must also cost the same as Sun Chips. They must all cost the same amount. Okay. Well, now I've just shown that angle 1 is congruent to angle 5. If those are congruent, what must that say about P and Q? Well, those are two lines being cut by transversal M. Now M becomes the transversal. And if two corresponding angles are congruent, then the lines must be parallel. So I have proven that P must be parallel to Q. And the way I write that is kind of in a sentence. If corresponding angles are congruent, then lines must be parallel. And there we have it. We have shown that just because angle M and line M and line N are parallel to one another, and angle 1 and angle 16 are congruent, that also lines P and Q must be parallel. Okay, and we get into triangle congruence proofs. So again, we can do a flow chart, we can do a 2-column, or we could do a paragraph proof here. I'm going to go with a flow chart proof. Okay, and that involves making boxes with each of my statements. So I start with a statement, A is congruent, angle A is congruent to angle D, and that's given to me. I like flowchart proofs because they let me see how this all goes together. So I mark that on my diagram. Angle A is congruent to angle D. Separately, segment AB is congruent to segment DE, also given. So AB is congruent to DE. And so right now, looking at those two triangles, I have two pairs of corresponding parts. And I know my triangle congruence criteria, SSS, SAS, ASA, AAS, that's how I prove triangles are congruent. And I need 3 pieces that are congruent, 3 parts that are congruent. So is there anything else in that diagram that we could mark congruent? And hopefully you're thinking, these 2 angles must be congruent. Okay, and I don't say angle C is congruent to angle C. I say angle ACB. I need to use 3 letters because angle C could be a lot of different things. Angle ACB is congruent to angle DCE. And why is it that those are congruent? Oops, I was about to write given. That's not given to us. I know that those are congruent because they are vertical angles. Remember we talked about those? And so now I have 3 parts that are congruent. And once I have 3 parts, this is why I like the flowchart proof, I literally see these 3 pieces coming together and allowing me to say that the triangles must be congruent. So triangle ABC is congruent to triangle DEC. And that is by, if I look at this, I have a side, an angle, and then another angle. Or I could think about it, angle, angle, side. So that side is not included. I have 2 angles, and then a side that is not, it's not in between those 2, it's after them. It is not the included side. So those 2 are congruent by AAS. Okay? And then that's, if you look back at what we need to prove, which I glanced at before I even started this proof. Oh, that's not a good highlighter color. If I look at what I'm trying to prove, it is that CE is congruent to CB, that those 2 segments are congruent. Well, once I know the triangles are congruent, then I know all of their parts must be congruent, because that's what congruence means. All of the sides and all of the angles are congruent. So now I'm going to say CE is congruent to CB. And that is because corresponding parts of congruent triangles are congruent. Okay? That just means once the triangles are congruent, sides are congruent, and their angles are congruent. CPCTC. Okay? On to number 39. Yet another proof. And so we are going to make a 2-column proof here. Again, if you prefer a flowchart, go for it. I'm going to put my statements on one side. I'm going to put my reasons on the other side. And I start with, what do they tell me? C is the midpoint. Of BE, of segment BE. Okay? Well, what can I mark there? Because that is not a congruent statement as it currently stands. What is that telling me? C is the midpoint, so this point is right in the middle of BE. What can I deduce as congruent then? Well, I can say that this must be congruent to that. That's the only way that C would be the midpoint. So I actually want to state, first I want to say that that was given to me. But I always need to follow it up with a congruent statement. If they don't state that something is congruent, I need to say that it's congruent. So I'm going to say BC is congruent to CE. Okay, I have one of my 3 congruent statements. Okay, on to my next given. And that is segment AB is congruent to segment DC. Right here. Oops, I need to go back and give a reason for why I wrote that. What is the reason that I marked those congruent? That is the definition of a midpoint. I knew that a midpoint would be right in the middle, so I was able to say, must split those evenly into 2 congruent parts. Okay? And finally, I'm going to get, so far I just want to recap, I have 1, 2 congruent statements. Okay, and I always need 3 congruent statements, unless they're right triangles where I can use HL, but I need 3 congruent statements usually. So I need to keep going, and I have this here. AB is congruent, I'm sorry, not congruent. AB is perpendicular to BE, and DC is perpendicular to BE. Okay, so what does that mean on my picture? I need to think about what I should label on my diagram and then what I can write in my proof. So this was given to me, but again, that's not a congruent statement. I need to see what can I say is congruent as a result of that statement. So AB is perpendicular to BE. That means this is a right angle. Oh, and I never even marked those were congruent to each other. And DC is perpendicular to BE. So those are 2 90-degree angles. Okay, so since I knew to mark those as 90-degree angles, that's what I should write here. I should say angle ABC and angle, what is that up top there? DCE are right angles, because that's what I drew on my picture. How did I know to draw that? That was the definition of perpendicular. Okay, do I have a congruent statement yet? No, I still do not have a congruent statement. But what do you know about those 2 right angles now? I know that angle ABC must be congruent to angle DCE because all right angles are congruent. right? They're all 90 degrees, so they must all be congruent. And there I have my third congruence statement. Okay, so now I have 3 congruence statements, and if I go back and look up here, what can I say about the triangles now that I have 3 congruent statements? Well, I can say the triangles are congruent to one another by SAS. Okay, so I'm going to write that. I am going to say triangle ABC is now congruent to triangle DCE by SAS. But again, that's not what they wanted me to prove. They wanted me to prove that angle A was congruent to angle D. Well, once I know that the triangles are congruent, I know that all of their angles are congruent and all of their sides are congruent by CPCTC. Do you remember what that stands for? Corresponding parts of congruent triangles are congruent. All right, what a proof. That was a good one, big one. All right, and we move now into Unit 2, Topic 1. So at this point in the year, you would have finished your study of congruence and moved into similarity, okay? So this is not where we have congruent triangles where all the sides and all the angles are congruent. Here's where the sides are proportional and the angles are congruent, okay? So in the figure here, DE is parallel to BC. So I have 2 segments here that are parallel. DE and BC are parallel. So I can prove that triangle ADE is similar to triangle ABC. Now remember, to prove similarity, I don't prove sides are congruent. I prove sides are proportional, right? And angles are congruent. So I can prove that triangles are similar using AA, SSS, or SAS. Okay, and there are a couple ways that I might do this problem. But when I see that there are parallel lines, because that's what's given to me, I'm going to list that as my first statement. DE, segment DE is parallel to segment BC. And that, oops, not 1, or not 2, but 1. That is given to me, okay? And when I know that those lines are parallel, I know that this angle is congruent to this one, right? Because I have 2 parallel lines cut by this transversal. And do you remember what those angles are called? Angle C, oops, angle CBD is congruent to angle EDA. And those come directly from the parallel lines. Those are corresponding angles. Okay? And now from here, your proof could take one of 2 directions. I might come up with another pair of corresponding angles because angle BCE, this angle here, is also corresponding to this one. So those must also be congruent. I'm going to take a different direction though. I want to say angle A is congruent to angle A. That's saying this angle is congruent to itself, which is kind of a funny thing to say, but we know that any angle has to be congruent to itself. And what do you know about angle A and those 2 triangles? Well, it's part of the big triangle, right? It's one of the angles in the big triangle, and it's one of the angles in the small triangle. And I always say that something is congruent to itself by the reflexive property. And now I have 2 angle congruences, and so I can say that triangle ADE is similar to triangle ABC. And that is by AA, because this was an angle, proving angles were congruent. This was proving an angle was congruent. And quite frankly, once I know two angles are congruent, the last one also has to be congruent because the angles have to add up to 180 degrees. Okay, so once the triangles are similar, I can think about the sides all being proportional. Okay, so I'm going to delete this proof so we can answer these other questions. Determine the value of x is what part B says. Well, when I know that I have two lines that are parallel like this, the side-splitting theorem says that that has split those segment DE has split the sides proportionally of the big triangle. So for part B, I can say 15 is to 9 as x is to 12. Okay? And that's because the sides are split proportionally, so I set up a proportion. Those relationships must be exactly the same. And now I solve that equation to find x. So I cross multiply. I multiply 15 times 12, and I get 180 equals 9x, because I multiply this way. And I divide both sides by 9. And I get that x equals 20. And find the value of y. Now this is an important thing here. In the problem I just did, notice that I had a part and a part. So 15 was part of a side, 9 was part of a side. So I said this part of a side has that same relationship with this part of a side. Okay? In part C, when I'm looking for y, though, I can only compare y to 30. And what do you notice about y and 30? Well, they are both a side of one of the triangles, not a part of a side, but an entire side. So the y is the whole side of a small triangle, and the 30 is the whole side of the big triangle. So I have to approach this differently. It's not part to part and part to part. This is a whole side of the small triangle, whole side of the big triangle. So I need to say a whole side of the small triangle, here's the 9, but I need the whole side of the big triangle, which is 24. I add the 9 and the 15. So side of a small triangle, side of a big triangle, side of a small triangle, side of the big triangle. So I cross multiply, and I get 9 times 30 is 270 equals 24 times y is 24y. And divide each side by 24, and I get that y is 11.25. And if you wrote that as an improper fraction, you'd get 45/4. Okay, moving on to more similar triangles. This is a word problem. So Jory wants to measure the length L of a pond. The figure below shows the measurements she'll use to determine the length of the pond, because she can't measure straight across the pond. That's all water there. So she has some other measurements. And in the figure below, AE and BD intersect at this point here. Okay? Which similarity postulate can you use to prove that those two triangles are similar? Notice the symbol here means similar. So they're not congruent to one another, but this is suggesting that they must have congruent angles and proportional sides. So at first thought, I might say 20 must be related to 50 and 25 is to 40. But that doesn't seem to make any sense. So if I think about it a little bit more, 20 has the relationship with 40, it's doubled, that 25 has with 50. And so I can show that 20 is to 40 as 25 is to 50. Right? I'm doubling here. I'm doubling here. So the bottom triangle must be twice as large, a scale factor of 2, to the top triangle. So this is showing me that 1/2 does in fact equal 1/2. Those two sides are proportional, but I only have two sides that are proportional, and that's not enough to prove that triangles are similar. So additionally, what else do I know is true about those two triangles? Hopefully you're thinking something about these two angles here. What's true about those two angles? They must be congruent because they are vertical angles. So we can actually use SAS to prove that the triangles are similar. Okay? And once I know that, once I know the triangles are similar, then I can set up a proportion to find L. So 20 is to 40 in the same way that 30 is to L. So 20 is the side of the small triangle. Here's the corresponding side of the small triangle, as 30 is to its corresponding side of the small triangle. So I'm going to cross multiply. I get 20L equals 1200. I divide each side by 20, and I get L equals 60 feet. My final answer. Okay, and this is what we keep saying about similar figures. Corresponding sides. The sides are not congruent because similar figures can be larger or smaller. So corresponding sides are proportional, while corresponding angles are congruent. All right, here we're going to prove that two segments are parallel to one another. So if I know that these two figures are similar, we just said that all the sides are proportional and the angles are congruent. Which of those is more helpful when we're talking about parallel lines or trying to prove that lines are parallel? That is that the angles are all congruent. So in our proof, it's going to be a relatively short proof. We are going to say that triangle QRS is similar to triangle QTU, and that's given to us. And if those two triangles are similar, then angle R and angle T must be congruent. That's because all angles in similar figures are congruent. And if those two angles are congruent, what kinds of angles are they? Well, it's telling us that RS must be parallel to TU because our angle, oops, I should back up a little bit. Angle R is not going to be enough for us to say here because is angle R this one or is it that one? I don't know. So let's be a little bit more specific. Angle QRS is congruent to angle QTU. Okay, so now if those two angles are congruent to one another, then the lines must be parallel because if two corresponding angles are congruent, lines cut by the transversal, lines cut by must be parallel. Okay? So once we know that those corresponding angles are congruent, the lines have to be parallel. Okay? And the last part of this problem is write out all congruences and proportions using the sides and angles in the figure. So my congruences are going to be the angles, remember. So angle Q in the small triangle is congruent to angle Q in the big triangle. Okay, and angle Q, there's only one Q, so I don't need to be more specific. I said in my proof above, angle QRS is congruent to angle QTU. And then my last congruence is that angle QSR is congruent to angle QUT. Okay, so those are all of my congruences. The only thing that I have now are my proportionality statements. So I know that the measure of QS, and when I talk about measures, I don't use a bar. QS is to QU, that's the side of the small triangle is to the side of the big triangle, as SR is to UT, as QR, last side of the small triangle, is to QT, last side of the big triangle. So those are all of my congruences and proportions that I can write. All right, the figure below shows triangle BCD, and we're going to have triangle B prime, C prime, D prime after a dilation. So dilation means that it's getting larger or smaller with center B and scale factor 5. So from here, this is my center, everything will get 5 times as large. Okay? So if I take my compass and I see how far it is to get to C, C prime is going to be 5 times as far away. And I don't actually need to do this, but I want to think about how to do it to complete the statements. Okay? So the point B prime will be the same point as point what? Okay? Well, if B is my center and everything has to be 5 times as far away from the center as it currently is, well, how far is B from the center right now? 0 distance away. So when it's 5 times as far, how far will it be? 0 distance away. So even with a dilation with a scale factor 5, B prime is going to be in the exact same spot. Okay? C prime, D prime, if I think about just making this 5 times as big, and this is not exact, but just trying to give you an idea, if I make that 5 times as big, what's going to be true about C prime, D prime, which would be down here? C prime, D prime is going to be down there. It's going to be parallel to, I'm going to delete this so we can see it, it's going to be parallel to CD. Okay? B prime, C prime, well, like we just saw, this is just going to keep extending down to be 5 times as long. So B prime, C prime will be on the same line as BC. And finally, the perimeter of triangle B prime, C prime, D prime, well, each side is going to be 5 times as large, so the perimeter will be 5 times as large as well. All right, so those are all the pages we are going to do today. Tune in to our next video to learn more about pages 19 on. All right, good luck on your exam.